Okay, so for this problem, we are given the specific weight of the soil when it is banked as 2,800 pounds per cubic yard. And then we're given the volume of soil as 1 cubic yard when it's banked, 1.1 cubic yard when it's loose, 0.95 cubic yards when it's compact. And we're asked to find the loose and compact specific weights. So the first thing I'd like to point out is kind of this notation we have over here that we can use for volume, right? So one way you can write this is you can say V loose equals 1.1 cubic yard, right? But another way you will see that written through some of the slides and some of the assignments is whenever we give a volume, the volume units will include LBC for loose, banked, or compact, just as another way to kind of drive home this is the volume in this state, vice another one. It's just one way to help keep track of all the different volumes and specific weights that we're going to be throwing around. All right, so the relationship we need to use to solve these problems is that weight is equal to specific weight times volume. That just comes from the definition of specific weight, right? Now, what we're going to use is we're going to use the fact that no matter what state you put your soil in, the weight of the soil doesn't change. This is pretty much conservation of mass, right? No matter how much you compact it or how much you aerate the soil, 2,000 pounds of soil is 2,000 pounds of soil, no matter how dense or loose it becomes. So what we end up with is that the weight of the soil is equal to the banked specific weight times the banked volume. And that's also equal to the loose specific weight times the loose volume, which is also equal to the compact specific weight times the compact volume. And this is kind of the powerful formula you're going to use to solve most of these problems, right? So here's an example where we can get it. So we're asked to find the loose specific weight of the soil, right? So we know the banked specific weight, we know the banked volume, we know the loose volume, and we know the compact volume. So what we can do is we can set up an equation using the banked information and the loose information and say banked specific weight times banked volume equals loose specific weight times loose volume. And at that point, we can just plug in 2,800 pounds per cubic yard times 1 cubic yard is equal to the loose specific weight times 1.1 cubic yard. And if you solve through, you get that the loose specific weight is equal to 2545 pounds per cubic yard, right? And then we can do the exact same process with compact, right? We'll use the banked information because we have all of that, and the compact information because that's what we're trying to solve. So banked specific weight times banked volume is equal to compact specific weight times compact volume. We can substitute in 2,800 pounds per cubic yard times 1 cubic yard is equal to the compact specific weight times 0.95 cubic yards, and we get that the compact specific weight is equal to 2,947 pounds per cubic yard. But there's kind of a second way of doing this that you can use as well. So this is kind of a relational way where you look at the specific weight and the volume for one state and compare it to another. Now, some of you might think better in terms of, hey, I know the banked specific weight and I know the banked volume, so I can find the total weight of the soil. The weight of the soil is equal to the bank specific weight times the banked volume. So the weight of the soil is equal to 2,800 pounds per cubic yard times 1 cubic yard. So we have 2,800 pounds of soil. Well, we know that mass is conserved, or in this case, weight is conserved. So we can rewrite these expressions to say that the weight is equal to the loose specific volume times the loose specific weight times loose volume. And hey, look at that, 2,800 pounds is equal to the loose specific weight times 1.1 cubic yard. And if you divide through, you get the same answer of 2,545 pounds per cubic yard. And you can do the same thing setting it up with compact, right? So that's kind of two ways to go about doing these problems. One way is calculate the weight and then keep the weight constant and solve for anything else you need. The other way is kind of relating different states to each other. Both are equally correct. Both will get you the right answer. For this problem, you can go about doing it either way. For other problems, one way or the other might be more useful, and we'll see that through other examples.